Okay, so this video is going to help us with section 9.3.3. And this section we're going to be talking about actually finding complex roots. Every number, real or non-real, has an infinite number of complex roots, whether they're square roots, cube roots, fourth roots, and so on. So if you want to find these specific roots, we're going to use this given formula to find. If you need to find square roots, you would your n value would be 2. If you need to find cube roots, your n value would be 3. I've shown here two formulas. The book gave us a formula for, if you're looking at these in terms of radians, which would be this formula. And then I've handwritten out the formula that you would use when you're working in degrees. And for most of these problems we've been working with in the book, we've been using degrees. So here's the formula that we're going to be using if we're finding complex roots and leaving our answers in degree form. It's the same formula. The radian one obviously uses 2 pi, whereas the degree one uses 360. So, for example, if we're given a problem like this that says find the complex cube roots of -1 plus root 3i. Leave your answers in polar form with the argument in degrees. So the first thing we need to do to be able to use this formula, if you look at this formula down here, you'll see that we need the equation or the number in polar form, not rectangular form, which is the form that was given to us. So first we need to convert to polar form. So to convert to polar form, we need to find r and theta. So to find r and theta, let's go ahead and graph our angle. And we know that this angle, since we've got a negative x value and a positive y value, it's going to look like this. Not very good at drawing these triangles. Okay, so I'm going to make this triangle a little bit bigger so we can actually see it. And let's fill out what we know in the triangle. We know that the x value, or the real value, is -1. We know the y value is root 3. So hopefully you can see now that this is going to be a 1, 2, square root 3 triangle. So our hypotenuse here is going to be 2. And then we can deduce here that this angle is going to be a 60-degree angle, and this is a 30-degree angle. Again, if you don't already know that, you can always find that using the Pythagorean theorem or using tangent inverse. Okay, so now that we know those side lengths, to find r, we know our r is going to... Okay, the recording cut off at some point. I hope it didn't cut off too much. We're looking for r here, and we know r is the hypotenuse of our triangle, which is going to be 2. And then our theta is going to be this angle. And since we know from this triangle that this is 60 degrees right here, and we know that this is 180, then we know that this angle is going to be 180 minus 60, which is 120. So our theta is going to be 120 degrees. So now that we know r and theta, we can give the polar form of our equation, which is going to be z equals 2 cosine 120 plus I sine 120. So this is the polar form of our equation, or our complex number. Okay, so now that we have it in polar form, we need to figure out what the complex cube roots are. Since we're finding cube roots, there are going to be 3 cube roots, because they are cube roots. If it were square roots, there would be 2. We're going to call those 3 roots, we're going to call them z sub 0, z sub 1, and z sub 2. So when you're finding roots, you always start with z sub 0, and then you count out the number of roots that corresponds to that particular problem. Since there are 3 roots, and we start with z sub 0, our final of the cube roots is z sub 2, not z sub 3. Okay, so once we have that mapped out, let's go ahead and write out the generic equation for these cube roots, z sub k, that, we'll write out the generic equation that actually applies to this particular case. Oh wait, hold on, our screen is freaking out on me here. Okay, I hope that's a little bit better. Okay, so if we're gonna write out the generic z sub k formula for this particular situation, we're gonna say z sub k is equal to n, and I'm referring to this formula right down at the bottom. Z sub k is gonna be equal to n. N is 3 because it's a cube root. The cube root of r, which is 2, parentheses, cosine theta sub 0, which is 120, over n, which is 3, plus 360 over n, again, k, plus I sine 120 over 3 plus 360k over 3. Nope, we're in out of room here. So when we simplify this, we get z sub k equals the cube root of 2 times the cosine of 120 over 3, which is 40, plus 360 over 3, which is, was that 12? No, 120. Wait. Okay, so 360 over 3 is 120k. And I should have parentheses, not brackets there. Plus I sine 40 plus 120k. Oop, oop. So now that we have that formula written out, we've done all the work. Now we need to figure out what z sub 0, z sub 1, and z sub 2 are, which is kind of the simplest part. So we just plug in what we know. Z sub 0 is going to be cube root of 2 times cosine 40 plus I sine 40. Z sub 1 is going to be the cube root of 2 cosine of 40 plus 120, which is 160, plus I sine 160. And z sub 2 is going to be the cube root of 2 times cosine 40 plus 120 times 2. So 40 plus, what is that, 240? So that'd be 280 plus I sine 280. So now do you see that we have the 3 cube roots all written in polar form? If we want to convert those to rectangular form, we could. We could just multiply everything out and distribute, and we would have 3 cube roots. I hope this helps. I'm going to post another problem so to kind of give you a better idea of how this works. I know this got a little bit crazy at times. So I'll post it in just a little bit.